Okay. All right. Hey. Okay. Today we're going to take a few notes over the trig functions. Goal today. We're going to introduce a new one today, which we're going to introduce tangent. Tangent is quite different than the others. Okay. It's quite different. You do need to pay attention. It has a different period length. The picture looks very, very different than the others. We're going to add this to our collection today. We're going to get 3 new problems. 3 new ones. Now, hopefully, you were working on the other ones, so you're done with them. That's what I'm hoping. Because I know some people turn them in, that's great. But if you haven't, you need to get those others, up to now, we have 6 of them. You need to get those done. The sine and cosine, we did those yesterday. If you're gone yesterday, maybe I'll do an example after we're all done, so you can see kind of what I did yesterday. Because it's an easy thing. It kind of looks like sine functions. Tangent's not. So that's our new one today. So here we go. We're in section 4.5. It's our last part of 4, 5 today. And Monday we're going to go into the next section, which is all the reciprocals. We're going to be dealing with the trig functions still, but we're graphing them.
Someone can choose the chair.
All right. So, all right. So let's do the trig functions. We're going to do tangent today. This is our main focus, to get to tangent. My goal is to do 2 or 3 examples of this, so you really know kind of how this works. You feel comfortable with it. That's what we're going to talk about. The easy part about tangent is that the way it's structured is always the same. Like sine and cosine can dramatically change depending on numbers, but tangent really doesn't. It's kind of nice the way that this works, especially the graphs. We're going to go through that. Now, once we're done with the tangent function today, and we go through a couple examples of how to mess with how to mess with amplitude on it, which really won't look like a change in the picture, or to mess with the period length of it, or the shift in that picture today, because we have to do all 3. That's going to be one of each type we do today. If we have a little bit of time, because I do want to give you a little bit of time to work today on this new assignment, because I'm going to add 3 more today. So our last ones, which I'll make them due Monday. And it's actually due Monday. You have to turn it in Monday. The idea is we have a little bit of time. I want to talk about the secant function today. And that's the reciprocal of cosine. And I just want to do 1 example of it. I don't need to do 2, but I want to do 1 example of secant because it is a reciprocal. And I'm trying to introduce them as we go. It's the reciprocal of cosine, because we did cosine yesterday, so maybe that's a nice review to how to do cosine right before I give you your homework today. But that's kind of the idea. We don't have a lot of time in here. I think we're out of here at 1:30. So yes, we have about 20 some minutes here to kind of get through this. I'm going to go through this as quick as I can. Make sure you are writing these down. Let's do the tangent function first. So tangent of theta, and this will be my function that we're going to try to graph, the tangent function. It still has the 3 numbers in it, but the pictures are going to look very different than the others. So it still has the C number, the A number, and the B number, like always, and they still affect the same idea. They still affect period, amplitude, and shifting in the same respect, for A, B, and C. But the problem is the period length for tangent is not 2 pi anymore. Okay? No way. Tangent's different. Tangent, if you look at the picture of tangent itself, like when you go through the unit circle, it only goes through 180 degrees before it repeats again. It doesn't go through a full 360. So it's actual period length that we're going to be dealing with here, and how this would affect you is it will affect this right here. The period length for tangent is just pi. It's not 2 pi. So that's something we're going to have to look at. Now this is going to be different, so don't think that we're going to go out to pi and then make our 4 hash marks. A little bit different because I said the pictures look a little strange. All right, but here we go. Let's just deal with the original tangent function. I would like you to draw a coordinate plane, and you do need both sides of it, not just the right side, like we did for sine and cosine. For the sine and cosine, we just went to the right, and we did our 4 hash marks. You need to draw, the perfect, coordinate plane, the T intersection. You need to put 2 hash marks going this way.
But do you need the bottom half?
And the 2 hash marks going this way. Yes, you need both.
That's yep. You just said you only use 180 of it.
Yeah, 180 for the period length. Period goes right and left.
Amplitude.
Amplitude goes up and down.
That's 180 also.
Yeah. Good question. These things we gotta figure out. All right. Now, here's the part we have to modify. Okay. The fourth hash mark, because I know there's 4 hash marks on the board. This hash mark is not pi, because there's 4 going on each side of the of the y-axis, I should say. So this whole length is pi. The whole thing, the whole picture is pi. It's 180 degrees all the way across. So that means if it's 180 degrees across, then yeah, this side over here is 90 degrees of it, and this side over here is 90 degrees of it. Or I should say pi over 2. Okay, so that's what you have to be thinking of, right? That it's half and half. So even though the full period length is pi, 180 degrees, like I said, but only half will be on the right, half will be on the left, because you're separating over the negative sign, right, over the 0. So how this works, the fourth, or this, I guess the second hash mark over here is pi over 2. This marker over here is negative pi over 2, because it's half and half. So how I always figure this out, once you know what your period length is, like what your full period length is for the picture, just cut it in half, and that goes on each side. So then, yeah, so then now your next one, you're absolutely right, these will be pi over 4s. Because you have to cut it in half to get the middle ones, negative pi over 4. So that's how you do it. It's very different than sine cosine, right? Sine cosine, you go out to the fourth hash marker, you cut it in half, multiply by 3. We don't have to do that here. We're basically just cutting in half to find the markers, and then we cut those in half one more time. So I think this is a little bit easier than the others. Now, on tangent, at 90 degrees and negative 90, there is an asymptote. There's an asymptote on the far edges. If you were to type in tangent of 90 in your calculator, it would say undefined, domain error, whatever it is, because you can't actually take 90 degrees in tangent.
What's your first shot?
So you'll have undefined points on the outsides. And now tangent, as you get closer to 90, since it's reaching an asymptote, that means it's going up to positive infinity over here. Okay, it will eventually hug up right against it. As I get closer to the negative side, it'll be hitting negative infinity down this side. So that's where the tails are going to end up at. Now in the middle, that's where you have to worry about your period length. Now we're just dealing with the tangent here, 1 tangent of 1 theta, whatever you want to call it, right? So my amplitude is just the number 1. I'm not shifting up or down. So I'm going to hit a peak of 1, and I'm going to hit a valley of negative 1 at certain markers. Okay? And how this works for tangent, it's going to look like an S shape, kind of like an S. So it's going to start in the upper right corner. It's going to loop down until it hits 1 at pi over 4. It's going to go through the origin, and then it's going to hit negative 1 at negative pi over 4, and then it's going to go down to negative infinity from there. So that's how the hash marks work, and it looks like an S shape. Now if I do a better job at drawing this, this is what it's going to look like.
Oh, your marker is marked.
Your marker's busted.
I noticed. Alright, there you go. That's what you're looking at right there, that's tangent.
That's a little different.
That's a lot of different,
wacky,
right?
per se.
It's very different. It's not that flowing, wave theory again. This has definite, distinct breaks in the graph itself. This one is one that, has practical uses, but for like wave theory, this isn't something that we could associate with, with sound or visual, the visual spectrum. So this is something that's very, very different. But I do want to show you the main trig function, so that's why we're doing it.
So what would this be used for?
So, good question. Honestly, I honestly haven't ever seen a practical application of the tangent function, of like the graph of it. I know, like it's something that I never had to use. I'm almost positive that it has to be something in engineering that I just didn't ever experience. Like sine and cosine I understood, like if there was sound, I saw the waves and they showed me tons of examples of it. But tangent, I don't know. I know what the tangent function is used for to find heights of objects or the length of an object, but the wave part of it, I've never used before, other than, I guess the one application I would ever use for is just to guesstimate what an answer is. That would be the only real, and that's stretching it. Like that would be the only thing I would really use it for. Like if I had to find like tangent of 30 degrees.
So it's really
30 degrees is like in here, so I can like kind of guesstimate what tangent would be.
So you're telling me there's a chance that this one might be completely useless.
Yeah, it might be. Other than just guesstimating numbers, but what we have to do is it's one of the main three. We do have to know how to graph it and stuff.
Does that mean?
I'll see for Monday if I can find some really like out there ideas like what we use it for. But for me, I haven't had to use it.
Well, probably use it like aerospace engineering.
Yeah, there's gotta be something.
They probably use it to send the outside.
These will be on the side. The main three. Yeah,
It's
the main
used for
three.
space toilets. That's what it's used for.
Alright. Okay, hey, but I'll try to find a stretch for Monday. Okay, I'll find it. Alright. Hey. Okay. Alright, let's do this where I'm gonna mess with the numbers now. So let's say I'm gonna go 4 tan 3 theta. So 4 tan 3 theta. So the only thing that it's gonna affect,
Goes up to 4.
okay, it's gonna, yeah, it'll hit the amplitude of 4 and -4. So 4, -4. So the amplitude is affected. And now the hash marks going across, instead of, having a total period length of pi, you have to divide by the number that's in front of theta. So that's what pi, that's pi over 3 now. So that is gonna be my whole distance across. Alright, now, that means that my numbers here are gonna be affected. So, if my whole period length is pi and I divide by 3, because that's my number here, what I have to do is I have to cut this in half. So this is pi over 6, this is negative pi over 6. Then you have to cut it in half again. Pi over 12, negative pi over 12. There you go, there's your graph. It looks like the exact same graph as the last one. It's just amplitude was affected, went up to 4, -4. It hit 6 12s instead of, just pi over 2s and pi over 4s. Because you had to figure out the full period length, which is pi over 3. Because you always have to divide by the number in front of theta. But then you had to separate in half and half on each side. Okay, questions, comments about that one? Now, next one. Let's throw in a negative sign.
Negative 3.
Then we'll do one where we shift it up and down.
Negative. We'll do up and down 3.
Okay, here we go. Alright, anyone still need the example though? Going a little fast, sorry. Okay.
Reese, do you have ADHD?
Absolutely not.
I don't believe that.
It's really got that too. Alright.
I wish I knew different.
Okay,
No, I think you would just said that.
just stop talking. I'm getting a headache already from you guys. I haven't been in here for 10 minutes yet. Alright. Let's go through another example. Let's do a shift here, and let's do some negative signs in here. So let's do the negative sign first. I think that's one we probably should look at. This example here, let's go with tangent, and let's put a negative sign out front, and let's put like a fifth in here. I'm gonna put like kind of a weird number on the inside. So this will affect my period length, and we're gonna flip the graph over. So when we actually draw this,
You're starting top left.
okay, yeah, we're gonna start in the top left and kind of work our way to the bottom right, because the whole graph is being flipped because it's reflecting. Now, we still have 4 hash marks going across, like this. They're just separated on both sides of the equality, or the y-axis. My period is normally pi, but what number do I have to divide by?
5.
1/5. And so you'd have to actually multiply by 5, so this is 5 pi. So this whole distance is 5 pi. Because again, when you divide by a fifth, you multiply by its reciprocal. And so that's 5 pi. So that means this side over here is 5 pi over 2. This is negative 5 pi over 2, because you have to split it half and half, whatever it is. Then 5 pi over 4,
That's a quarter.
and 5 pi over 4. And that's negative 5 pi over 4. Alright, so there's your numbers. On the outside, we do have the asymptotes still. So we have the asymptotes out here. We're going to go through the middle of the origin. I'll explain what just happened there in a second. Alright, so we're drawing that straight down. And now the idea is that I'm going to hit a peak and valley. Now my peak and valley here are going to be 1 and -1, because I didn't affect the amplitude. There wasn't a number out front, so I'm just going to hit 1 and -1. Alright, the negative means we're going the opposite direction. So instead of starting the upper right, We're starting upper left, and then we're going down. So it's basically taking the whole graph and just flipping it over. So this graph will start up here. It'll hit 1 here, 0, -1, but it will look like this. And it will hug right up against the asymptote and hug right up against the asymptote on this side. There's your tangent function.
Okay, so what just happened there?
It's just slide.
Graph was negative.
Not with the math thing,
Reflection?
the person coming into the room thing.
Oh no, I'll explain it after we're done with the lesson. So, I'm not gonna do it, I'm recording right now. Okay. Alright, last one I want to talk about, if we shift it up and down. The only difference would happen if we shift it up and down is you have to figure out where the new 0 is. So that will move up and down from here. It'll still have the amplitude from that number. So, you know, let's say we're gonna shift my picture up 6. Let's say let's up 6, okay? So let's go 6 plus tangent of pi theta, pi x,
Oh, that's
okay?
more.
So that means whatever my numbers are, my period length was affected, and I'm shifting my picture up 6. So this is my last example of the day. I probably won't get to the reciprocal function. All right, hey, does anyone still need this picture?
No, sir.
Okay, all right. So, can we stop talking, please? All right, so on this one, the normal period length is pi, but I have to divide by the number in front of theta. So really, the whole distance across my graph will be 1. So that means, you know, if the whole distance down here is 1 all the way across the origin for my period length, that means half of it will be over here,
Quarter,
and half will be over here,
quarter.
and quarters, yep, 1/4 and 1/4, and that one has to be negative. All right. I still have my my asymptotes are still on the outsides. Okay, and now what I have to worry about now is the shifting. Okay. So this is not my amplitude number, right? It's the shift. So 0, 0 isn't my main focus. I'm actually going to be up at 6. 1, 2, 3, 4, 5, 6. So this is 6. This is where I'm going to go through the origin at. Okay, it used to be 0, right? It used to go through 0. But now I'm going to go through 6. And it's going to start in the upper right corner still. It's going to come down, go to the lower left corner. But at these markers, it has to hit the amplitude from here. So the amplitude, if we look at the number in front of tangent, is a 1. So that means I'm going to have to hit a peak of 7 and 5 at these markers. So this marker I'll hit 7. This marker I'll hit 5. Because as I go through, I have to pass through 6 and then keep going.
Let's take a slide.
Okay, so it's really shifting this graph up, but my picture looks distorted because I put my numbers really close together, like 5 and 6.
We should
7. But again, how that works, your amplitude is from where that new center is. It's not 0, 0 anymore. I shifted up 6. And so you have to use the amplitude from that number. So if your amplitude was, let's say, 3, because that was the number we were saying earlier, you'd have to go 3 up from here and 3 down from here, and that's where I'll hit those markers. These two. But again, it's based on the amplitude number. Okay, questions on how tangent works?
No, sir.
Okay, here's your new assignment. Now, if you've already turned in your page 533, that's fine. I'll grade it. Maybe you wanted to separate it, it's fine. I recommend just add these to the back of it, because I'm going to grade it all as one assignment.
I enjoyed that.
Okay, here it is. You're going to need to be on page 546. You're doing 5, 7, and 10. It's all tangents. That's all it is. 3 problems. That's your last part of the assignment. When you're done with it, you can turn it in. Maybe you already turned in the other. That's fine. I'll staple it and grade them all at once.
So I just put on the back of this one?
But yeah, you can put it on the back.
Yeah.
Yep. But again, these are only tangents, but it's due Monday.
I have a question.
Due Monday. Everything on that assignment. That was
A quick turnaround this.
quick turnaround. But these were due today technically, so we shouldn't have that.
On the grade bucket says I got 5. And I got
52. I'll look.
Tell us the story.